Hello, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to continue working on the RBJ filters, but let me start by complaining. I use OBS to stream. As you may know, you probably know this if you're watching this stream. And today, OBS was just like, no, I don't want to work today. So, it was just crashing. I started a stream and it crashed over and over. I restarted the computer. That helped. We'll see. We will see. Okay, so I said that I was going to do some work off stream, and I did. I was a good boy. I read everything that we wrote together, I guess, in 2 streams already, in the implementation of the RBJ filters. So I read all these variable names, and I read all the code that we wrote for translating the formulas for the RBJ filters. I think that everything is correct. I checked twice or 3 times. I think that everything is correct. So today, what we're going to do is to actually listen to the effect. So I am going to write another page here on this demonstration effect. So far we have a page for tests, and we have a page for colors, and I'm going to add a page for filters. So we're going to add a page for that, and we are going to actually implement a simple filter. We're just going to call our library function. And I guess today is all about testing everything. So let's also test this stuff over here. And those are going to be unit tests, and they're going to be super simple stuff. Okay, so here is the definition of the exponential, the hyperbolic functions. I had to implement one of these, but I decided it was better to just implement all of them. One of these was actually used in the RBJ filters. That's why I had to implement it. I actually ended up implementing all of them. Who knows when they will be useful? And I believe that I missed some stuff at the bottom. Well, I don't believe that. I know that. These guys. Right? So if we have a sine function, we better have the inverse, an arc sine function. And I believe that JS effects have the regular trigonometric functions, the sine, cosine, and tangent, but they also have the inverses as well. See, a sin, a cos, a tangent. They even have this flavor, which is super cool, and we are going to use it when we do Fourier transform stuff. We'll get there at some point. Okay, so I guess since I implemented sine h, cos h, tan h, I'm going to implement a sine h, a cos h, following these formulas. But I'm going to follow this naming convention of just putting an a in the beginning instead of ar. All right, so we have a formula on the right, we have code on the left, and yeah. Let's implement these guys. Oh, come on. There you go. There is an article for the inverse hyperbolic functions. Maybe they have different formulas. Maybe they have the same formulas. Let's see. I think they're going to have multiple definitions. Yes. Yeah, I think that this is what I want. And the formula here is the same. The formula there is the same. That's the same as this one. This is the same as that one. This is all right. Okay. And these formulas over here are still useful, but mainly for when we are working on mathematical derivations of stuff, not when we just want to compute stuff. So I think that I'm going to go with this version. Oh, come on, go there. Can you please not move around when I resize the window? Thanks. Okay, so I'm going to follow these definitions over here. I'm going to implement them. And I'm going to test everything. So maybe I will have another comment for where the other functions are going to come from. And I believe they are going to be super similar, except that there will be an A in the beginning. Yeah, we have sine, and then cosine, and then tangent, and cotangent, and yeah, all of that looks correct. Now we just have to fix, of course, the formulas. By the way, I said that I was going to try to understand what the hyperbolic functions are. I mean, they are formulas that we can copy and paste, but I said that I was going to try to understand what they are. And I didn't really understand. The best explanation I have is, you know how trigonometric functions like sine and cosine, they can be defined in terms of trigonometry. Like if you have a triangle, then sine and cosine are related to like the sizes. If you divide the size of one side by the other side, you get the sine, the cosine, and the tangent. Well, another way of defining trigonometric functions is with a circle. So you can imagine that this is a plane and this circle is sitting on a plane, and then the sine and cosine are the lengths of a triangle that is defined by the two main axes, the x and y, and a point. So the line connecting a point in this circle. So there is, and of course these two definitions are related, and I guess we could even argue that they are the same. But my point here is that the trigonometric functions, sine, cosine, tangent, and so forth, they are related to a circle on the plane. Well, what if instead of a circle, you had a hyperbole? That's what sine, the hyperbolic sine, hyperbolic cosine, and so forth. That's what they are. Now, and the relationship is similar. So in the circle, the sine is on the y-axis and the cosine is on the x-axis. And here happens a similar story, but where does this hyperboles come from, and why is this useful, and why is this used on an EQ? I don't really know. Okay, now that I explained how I don't know stuff, let's actually implement these formulas. So this is the natural logarithm, which in JSFX is called just the log of x plus and then square root of x squared plus 1. Well, we have another function that we can call for squaring things, which is faster and kind of like the way that it reads as well. So this is about the same except for a minus. This is going to be a bit different. Well, if you have a division by 2, and then I guess another way of putting this is just log of something divided by 2, isn't it? And then what is it that you are dividing? It's 1 plus x divided by 1 minus x, like so. And the cotangent is going to be the same except that the signs are flipped. And this, I have two alternative definitions. At this point, I want to look at them and see if one is better than the other. I think that this guy is better because division is, I'm like counting the number of operations. There is a square root in both. There is a natural logarithm in both. But here there are two divisions, and here there is only one. And division is a somewhat slow operation. So I think I'm going to go with the one on the right. So it's the log of 1 plus, well, it's actually going to be everything divided by x, and then 1 plus the square root of 1 minus square of x. And then for this last guy, it is, well, this one I guess doesn't have a nice formula like this, so we have to just use all the operations in there. So it's the natural logarithm of 1 divided by x plus the square root of 1 divided by square x plus 1. And you may be thinking, do you need parentheses here? Not really, because the order of operations, the precedence of this is going to be do the division first. Okay, let's double check our work. Log of x plus the square root of x squared plus 1, and then the same except for the sign. Then the tangent is half of the logarithm of 1 plus x divided by 1 minus x. Our cotangent about the same except that, oh, no, hang in there. I did the wrong thing here. So the arc cotangent is incorrect. This should be, I flipped the signs. I shouldn't have. I should have flipped the operands. Like so. Right? So let's double check this. A logarithm divided by 2. What is in the logarithm? 1 plus x divided by 1 minus x. And on this version, x plus 1 divided by x minus 1. There you go. Now, this is the natural logarithm of 1 plus the square root of 1 minus x squared divided by x. And this is the natural logarithm of 1 divided by x plus the square root of 1 divided by x squared plus 1. There you go. Semicolon at the end. Okay. Now, I don't know when this is going to be useful. I really hope that it is useful to someone somewhere at some point. Let's commit these equations. Now, how do I even test this? Well, I have two ideas. The first idea is that we can try to pick some values that we know, and maybe like for x equals 0, the sine, the cosine, and the cotangent, they are all 0. That kind of thing. I could also just come up with random numbers and put them on a calculator and compute the result. Yeah, I can see that there is a discontinuity that we have to deal with. I mean, I don't want to divide by 0, though I can. That's an interesting thing about JS effects. If you divide by 0, then JS effects don't care. They're just going to give you 0 as a result. For instance, 32 divided by 0. And I'm going to put this window here. I'm going to peek, Command P, and that expression evaluates to 0. So it doesn't really matter. JS effects, they don't care about divisions by 0, as far as I know. But I think it's nice for me to check everything. So it seems like, yeah, the sine and cosine and tangent don't care about negative 0. It has no discontinuity. But this, so it's even it's over here. I just didn't notice. So if on the cotangent and cosecant, if they have any input that is 0, then these terms are going to be 0 on the denominator. Usually not a good thing. So I'm going to check for that. On the hyperbolic cotangent, cotangent, so this guy. If x equals 0, error. Otherwise, that. So I have to check this for the cotangent and for the cosecant, which is this guy. Now, I wonder if I need to worry about the same thing for... Did you notice something? When I put a new line, everything shifts. So I think that we are exactly at 999 lines in the code in this library. Fun stuff. All right, and what about the other definitions that we are using? The inverse. Well, they all have these natural logarithms, and logarithms don't like to be 0 or negative, right? We can look at the plot of the thing. Oh, they don't like to be 1? No, that doesn't make sense. Yeah, logarithms don't logarithms don't like to be 0 or negative. I mean, they don't like to receive arguments that are 0 or negative. Okay, I'm not gonna double check my memory of mathematics like this, but I believe that these logarithms need to be positive numbers. So let's check if they are going to be positive numbers. I mean, I can also use a calculator. Yeah, this is a complex number. I'm gonna try to avoid them. Yeah, that does not exist, but a very small number is okay. And negative numbers are okay in the sense that you could use imaginary numbers as an answer. But we don't have the notion of negative, of imaginary numbers. Not yet, anyway. So under what conditions is... Oh, let's see if they talk about the domain of these guys. For all inverse hyperbolic functions, the domain of the real function is connected. The domain... Oh, so they talk about the domain here. Not on this version, but over here they talk about it. The domain is the whole line, real line. For the cosine, the domain is the closed interval starting at 1. So I'm going to have to, and this is the kind of attention to detail that is going to set my library apart from everything else that you have ever used. I go to the Wikipedia and I read carefully. Cosine. So if x, if x is less than or equal to 1, error, otherwise return that. Oh, so the domain is the closed interval, so it is, this bracket represents closed, which means that I have to just do less than 1. If I have x equals 1, I have 1 plus 1 minus 1, which is 0. So the natural logarithm of 1 is going to be 0, right? It is. Okay. And then for this hyperbolic tangent, the domain is the open interval. So if my x is less than or equal to -1, or if my x is greater than or equal to 1, now this is an open interval. So it means that -1 and 1 are disallowed. And in those cases, I'm going to return an error. Let's see, hyperbolic cotangent. For this one, the domain is open intervals. Hanging there. I think I'm reversing all of these, aren't I? Oh, this is so complicated for me. I have such a hard time understanding these things. I just hate mathematical notation. I think it's the worst way of representing ideas. Okay, so sine. That's easy. The whole real line. Cosine is the closed interval. What is a closed interval, Wikipedia? An open interval does not include its endpoints. Okay, let's start writing this down because I'm going to get it wrong. I'm sure I'll get it wrong. Open interval doesn't or excludes endpoints, while a closed includes endpoints. Why don't they use the words inclusive and exclusive? It makes a lot more sense, doesn't it? I think it makes a lot more sense. An open interval does not include, it excludes endpoints. A closed interval includes endpoints. So for the hyperbolic cosine, the domain, the allowed values are a closed interval. It includes the endpoints. So 1 is allowed. And hyperbolic cosine, this guy. So 1 is allowed. Anything less than 1 is disallowed. I will have to write tests for all of these guys because I'm testing the boundaries of the domains and everything, because I'm sure I will get some of these wrong. Mathematical notation does not make sense, and the terms don't make sense either, like closed interval and open interval. Doesn't make sense. Inclusive and exclusive make a lot more sense. And brackets and parentheses don't make any sense. Just doesn't make any sense. I hate this. I hate it. I hate mathematics. I mean, I hate mathematical notation. Okay, so the domain is an open interval. Let's go to our cheat sheet and okay, so hyperbolic tangent. A domain is an open interval. It excludes endpoints, which means that -1 and 1 are disallowed. -1 and 1 are going to be an error. Okay, cotangent. The domain is using open intervals. It excludes these numbers. So -1 and 1 are disallowed, which means that if x is greater or equal to 1 and x is less than or equal to +1, I forgot to put the minus here. That's an error, otherwise it's okay. The domain is the semi-open interval. Oh, okay, so now I have to really wrap my head around open and closed. Okay, so open intervals are being denoted with parentheses and closed intervals with brackets. So the domain is a semi-open interval. So parentheses means excludes. So 0 is not allowed. And the bracket means a closed interval, includes endpoints. So 1 is allowed. If you're watching this and you have just, you flow through this notation and like it's nothing, and oh man, and then you're like, this guy's dumb. Cut me a break. I find it very hard. The domain is the real line with x removed. So if x is 0, that's an error. Oh boy, that was painful. That was so much pain. I think that I'm going to actually link to this instead of the other link I have because of this domain situation going on. Okay. You know what? My patience for this, guys, has expired. I'm going to keep the to-do here to test these guys. I'm not going to continue with this thread. I really want to hear a filter, and I don't have much time, so let's move on. I will get back to this and test this, I promise. So let's look at the RBJ filter situation. What do we have in our demonstration effect? So we are doing a library and we are also doing an effect to show off the library. I think that maybe at this point that I'm going to add a new page. When I'm iterating on the test, it's fine to have the test as the first page, but now I may want to have something else as the first page. I think I'm going to keep the test as the first page, and I'm going to do RBJ filters as a second page. Okay, and then we already have created an RBJ filter. Is that how you do it? Yes, that's how you do it. Then we need to configure that. And I guess I'm going to configure this here as well. But I think I'm going to move it to another place soon. But for now, let's start there. So we are going to need all of these parameters. Let's maybe have them side by side. Okay, so, or maybe I'll just put them here. I will need a type. I'm going to do the simplest thing, which is a low pass. The frequency is going to be like 1000 hertz. The type, let's use Q, or not. Maybe let's use bandwidth. Yeah, let's use bandwidth for a reason that will become clear in a moment. In fact, let me show you the reason, but not on this REAPER instance, on this one. So everything is still muted and all right, but I'm going to want to compare with ReaEQ. And they define the wideness in terms of bandwidth. And the bandwidth, so I'm doing a low pass. This is a high shelf. Let me do a low pass at 1000 hertz with a bandwidth of 2. Does the bandwidth even affect this? Yes, it does. With a bandwidth of 2 octaves. And then for the dB gain, it needs to be undefined because I am not doing... I forget. dB gain is only for peaking or shelving filters. So this configures the filter. Now, we actually filter stuff, right? We actually filter samples coming in. So let's have another block. We currently have an init block, we have a GFX block, and now we need a sample block. And I am going to check if my page is equal to this page. If so, then I'm going to loop over every channel and I'm going to filter every channel. Oh, no, I only have one filter. So I suppose I'm only going to filter the left channel. Yeah, I think I'm going to do that. Then how do I filter something? I call this function. And let's do a quick trick here. We're going to change that, I think, in a moment. But let's do this so that the filter is actually stereo. And then let's bypass ReaEQ and put some white noise before our... Oh no, there is a syntax error in our program. But we're going to put some white noise before we are going to produce some audio, and then we are going to use a spectrum analyzer at the end. No, not this spectrum analyzer for reasons that I don't want to get into, but this spectrum analyzer. Yeah, all right. So this is some white noise, all right. Let's see what the syntax error is. On line, in the library, line 112. Oh, I need to reload. That's what's going on. No, it just moved to a different line. So let's go to line 120. And I don't have any brackets. I haven't touched this in a while. So no, the error is somewhere else. In my library, in init 120. I was looking at the wrong file. That's what's going on. No, that's not what's going on. Error on init 120, syntax error. Well, we wrote this function today, so it could be wrong. It could have a syntax error in there, but I don't see it. Do you? Well, we are not actually using this function, so I guess I can comment this out for now. Let's see if when I comment this out, if it works. No, now it's just in line 144. And what is going on in line 144? Well, I think I see a pattern. It is when I'm starting to define a function. But no, I really do think that there is a mistake further up, which is preventing this from working. Yeah. Well, another thing I can try... no, not really. I was going to say that I could try to open this file in this kind of IDE, but this file is an include, so I don't think I can open a library in this editor. Oh, I didn't know this feature. That is cool. I can have multiple buffers here. And you can alternate with between them. Cool. And how do you close this? Okay, you close with Command W. And how do you get there? Just double click on the file. Okay, that's very good. Okay, so I can go to line 120 and see what the issue could be. Oh, that's what this is about. Missing one parenthesis. Recompiled okay now. Okay. Let's do a full compile reset. And we are producing noise, or we are passing noise through. This is our frequency analyzer, and it's time for the big moment. I'm going to switch to this, and I can see a dip. It works. It really does. Isn't this great? I have a lot of fun with this. I like this. I really do. And I mean, from a programmer's perspective, look at what you have to do to come up with a filter. You have to write these lines to configure the filter, and you have to use this. Isn't this great? Isn't this excellent? Don't you just love this? Yeah, okay. There is a story I have to tell. Okay, let's take a step back. The filters are working great. We are going to play with them, I guess, for the rest of the stream. I'm going to be playing, adding sliders, and just comparing it to ReaEQ. It will be a lot of fun. I mean, this is not the first time I'm implementing the RBJ filters. In fact, we did this in the stream already, but this is the first time that I'm going to actually experiment and hear it, make sense of it, and whatnot. But I have to tell a story. There's something else going on. I'll leave the suspense. For now, let's actually hear, with headphones, something that we did with a library, with this library, for the first time. There's something weird, right? The gain is all over the place. That doesn't seem right. I don't know. Okay, so I guess I will have to close some of these windows to make space. And I'm going to move this way further down. And then first, I'm going to just disable everything, and we should hear white noise. Oh, I'm not sure I have the correct routing here for this to work. Yeah, it's not routing anywhere. So let me route to my computer sounds. This way it should go to the stream as well. Yes, I hear white noise. Everything still seems to be all right. I'm not even in the page that is actually filtering stuff. All right, let's see if it's safe for me to switch between these two. It seems safe. The levels are not going up in a weird way, and there is no clicks or anything. So I think it's safe for us to hear this transition, and then we will be able to really tell that, yes, this is different. All right. We did a filter. Okay, so what's this story? Well, the reason why I wanted to build this library, one of the reasons anyway, I had many reasons. One of the reasons is that I want to do some things different in terms of memory management. If you go look at any good old plugin using JSFX and even the libraries, there are at least 3 libraries that I know of for JSFX. They always use these pseudo objects. I'm not using them. Instead, I'm allocating memory. Why am I doing it this way? Well, because you could just have a loop, and I think we're going to do that, in fact, in this episode. You could just have a loop to initialize a bunch of RBJ filters, and you cannot have a loop to initialize. Yeah, you cannot have a loop to initialize a bunch of pseudo objects. The pseudo objects need to be variables. So for that to work, typically what people will do is just they will copy things over. They will have some line, they will have something like this. Okay, so for the right and the left channel. And I dislike this for 2 reasons. The first is you have to copy and paste a lot of code. The second is you're doing a stereo effect when you could as well just write a loop, not copy any code, and you would have a multi-channel effect. But for that to work, you cannot use pseudo objects because they need to be actual variables. So the potential solutions for that are in the language itself. I mean, you could allocate memory instead of using the pseudo objects. And the second solution is I could write a programming language that compiles to JSFX. In fact, I don't have to do that. There are languages already that compile to JSFX. But I was talking about this yesterday. I don't really like this approach because it means that you have to compile everything before you can see, and you cannot just hot reload in REAPER. It's more things for you to learn as a programmer. So I wanted to try to do everything in the language, but maybe I'm hitting a wall. Because to do everything with memory allocation means that everything will be a lot slower. And I do have error checking all over the place. So things are slower. And I'm doing this error checking in the language. It means that anytime you're calling this function, you are going through the error checking. If I had a language that compiled to JSFX, maybe I could have some sort of type system in the language. Now, not really type system because everything in JSFX is a number, but I could have some sort of check, static checks. For instance, for these guys, they are numbers, but really what they are enumerations. So I could have this in the meta language that compiles the JSFX. But that's inconvenient for other reasons. So I wanted to give it a try and do everything in the language like we are doing. But maybe we are going to hit a wall. I don't know. Because look at this. All we are doing is filtering. One filter. It's not even that complicated. And it is already taking 1% of CPU. That's a lot. This guy is doing a frequency spectrum thing and it's not hitting anything. It's not using any CPU at all. Doesn't even register. In fact, our plugin is the only one that is like consuming a lot of memory. Or not memory, CPU. A lot of cycles. A lot of resources. So plugins that use this idea are going to be slower. That's not good. So maybe that's why people use pseudo objects to begin with, and maybe this whole idea was just it doesn't hold water. I mean, if that's the case, I will do the pseudo objects and maybe even use one of the languages that compiles to JSFX. I don't know. This is not super happy for me, but let me prove that I can use this. Bo says, I've missed the first 45 minutes. Gonna need to watch the upload. Hey, Bo. Great to have you here. Yeah, so in the first 45 minutes, we implemented the inverse of some of the hyperbolic functions we implemented before. I talked about what I know about hyperbolic functions, and I used the RBJ filter that we finished implementing yesterday. I used that, and it is working, but it's also starting to prove that my approach may not be the fastest. I was trying to avoid using the so-called pseudo objects in JSFX because they have all sorts of problems I just explained. But they are faster, I think. And this CPU use for one filter does not make me happy. Not at all. Not at all. I don't know. Yeah, let's push this to the limit. Let's see what we can do with this. So, yeah, I'm going to show how I would do the multi-channel stuff. I'm going to allocate multiple filters, and that will show the beauty of doing things with memory like I'm doing, but let's see what the CPU use is going to be like. All right, so let me create some RBJ filters, one per channel. For that, I'm going to need RBJ filters is going to be an array. And how many slots do I need? Well, if I want to be multi-channel, I need to be pessimistic and allocate 64 of them because that's the number of channels that we have in REAPER. And then I will loop over the channels. Oh, I don't think I'm able to do that in the init block. Can I do that in the init block? I don't know. Let's check. So in my init block, the question is, in my init block, do I have the number of channels available to me? The answer is no. So I cannot allocate, I cannot configure. No, what am I saying? That doesn't make sense. Okay, let's go back to this. We are going to implement this. So I'm being pessimistic. I'm going to allocate 64 of these filters. So for channel starting at -1, let's do a loop of 64 positions. And in this loop, we are going to array set. This is the array, position is channel, and the value is a new RBJ filter. Now just check this out. I think that this kind of code is amazing. It's multi-channel, it doesn't repeat itself, it's just great. I really like this. Let's see if we can pull this off, if JSFX is going to be good enough for this. Okay, so this is me allocating the filters. I'm allocating the memory necessary to hold their configuration. Then in the slider block, on that one, I do have access to the number of channels. Am I right? No? Oh no. When do I have access to the number of channels? Special variables, numChan, most contexts. Specify the number of channels available, usually 2. Note that SPL blah 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 are still available even if this count is less. Their inputs and outputs are just ignored. You can change the channel count available via in and out pins. And that doesn't make any sense. what is the context in which this is available? Oh, is it that I have to like touch a slider for this to run? That's it. Oh, I think I know what's going on. So as far as I can tell, there is this weird bug in JS effects that the slider block doesn't run in some situations, unless of course you come here and you touch a slider. And I remember, if I remember correctly, there is a way to force the slider block to run, which is to have a serialize block, and it doesn't really have to do anything, just has to exist. And see, now that works. Now this is a weird, I think it's a bug, and this is a weird, I think it's a workaround. But it is a workaround. So I guess it has to have and it even has to have, so see if I do a full compile reset, it cannot be empty. It has to have an expression. So I guess my expression is going to be force the slider block to run. And now debug is set. Now I wonder if the init block is going to have access to this variable as well. Oh, it seems like it has. But if I don't have the serialize block, then it doesn't. So the serialize block is a magic piece of, it's a magical thing. And I'm not even sure now that it prevents or it causes the slider block to run, or if it just lets the number of channels be available to other places. I don't know. I guess I will just have a value in here. I think that later we will have a better value to put there. But I don't know. I don't know. But if I have access to the number of channels in this, then I can just allocate everything in the right place. I don't need a slider block to do this. Yeah. Yep. Let me go back to Visual Studio Code. I don't like this IDE all that much. So instead of 64, I will allocate with the number of channels, because if the number of channels changes, the init block is going to rerun. So I think it's safe for me to do it this way. Alrighty. So I'm going to just put this in there, and I'm going to create an RBJ filter variable, which is this. And then I'm going to move this line to the end. Okay, what do we have here? We have an array called RBJ filters, and we are looping over the number of channels, and we are creating a new RBJ filter per channel. And we are already configuring them like so. And then we set on that channel. Okay. In other words, I'm initializing RBJ filters over here. Then for the sample block, if I am on that page, I'm not going to do the mono thing, and I'm not going to copy and paste any code. No, sir. I am going to loop over the channels, and for SPL at channel, I am going to array get from my filters the filter for that channel. And I guess I can call this my RBJ filter. And then I move this line up and delete this stuff. And there you have it. I mean, it's kind of silly to have an intermediate variable for this. I think I'll just do that. And this is the kind of code that I wish to write. This is what I want to write. It's all in JS effects. It's looping over the number of channels. Doesn't repeat any code. Just love the way that this works. Let's see what it looks like. Bo says, aren't the different blocks described in the documentation? I remember reading about that. Yes, but there are some weird interactions, like when you have a serialized block, the number of channels becomes available to the init block. That doesn't really make sense to me. But it seems like that is the case. So who knows? All right, so I did a full compile reset. And I still have all the audio routing, generating white noise and everything. So let's go to the RBJ filters page. And it's still filtering, all right? But it is filtering the left and right channels differently. See? I don't know why these are so weird. Are they supposed to be weird like this? We have a different effect, the ReaEQ, and it has the same settings. So if I do that, let's alternate between the two. They are supposed to give me the same result. And they seem to do. I'm alternating between the two, by the way. And here on my output, they seem to be doing very similar things. We are going to null test them. Don't worry about that. Bo says that, yeah, that's how the noise works. Great. And I guess it makes sense. Because at any given point, you have different frequencies being cut. Different amounts of the same frequencies being cut. So the level goes up and down a little bit. All right, I'm okay with that. It seems like this implementation holds water. Now, if I enable this, what does the CPU look like? Not good. It seems like it's 1% of CPU on my computer, which is, it's not a great computer, but it's not trash either. It's like 1% of CPU per filter. That is not gonna fly. We'll have to make this faster. Oh, that's so bad. I mean, because if you wanted to do like a simple EQ, you would have 4 bands per channel, and that's already like 8% of your CPU for a 4-band EQ. That's no way to be happy. Oh, that's so sad. Let's commit what we have though, because it is working. And I'm just going to move forward with this. I still have like 20 minutes. I'm going to move forward and I'm going to do some sliders, and we will do filter sweeps and we'll compare to ReaEQ. Or maybe we can start with the ReaEQ comparison. Yeah, let's start with that. So you mean for a 6 dB filter, that's a lot. But what do you mean the CPU use? Yeah, the CPU use is no way to live by. This is not going to be like that. I will have to think about something to fix this. Maybe the whole approach of using memory instead of pseudo objects is not going to apply. Or maybe it's just the error checking, and if I turn it off, things will be faster. We'll see. I'm looking forward to watch you solve this though. Yeah, I mean, I kind of already know the solutions. First of all, I am doing a lot of memory safety stuff. So in all my data structures, when I'm accessing memory, in all these places, I'm doing error checking. And I'm doing that while the plugin is running. I'm not doing this ahead of time. So this is a lot of work. This is a lot of work to do 48,000 times a second. That's why programming languages like C and C++ try to do the little bit of memory safety that you're going to get is probably going to be at compile time. During runtime, it's mostly going to be, it's not going, for instance, to check array bounds the way that we are. So this is going to be probably a source of problems. So I guess I will turn this kind of error checking off by commenting these lines out. I'm not going to do anything fancy. And if that makes things faster, then yay. I will just not have so much memory safety. I will have less memory safety. But if that doesn't work, then this approach of just being able to loop over channels like this and allocating memory like that, that approach will not fly. So if I cannot do error checking, I'm kind of okay, because during debugging, you may get most of your bugs during development. So if you don't have memory safety, that could be okay. But if I cannot do this, then I will be really unhappy. So we'll have to figure out. One source of performance issue is error checking. Another source of performance issues is that I'm using a lot more of the memory. I'm using, not just in terms of quantity of memory that I allocated, but mostly I am accessing memory a lot. And that could be slow as well. If I have everything in pseudo objects, I think that they don't necessarily need to go to memory. They can just use the cache in the processor, and there's like all sorts of optimizations with that. We'll see. For now, let's continue with the program. Let's null this against ReaEQ. As far as I can tell, from having watched Dan Worrell's videos, ReaEQ uses formulas similar to RBJ, so it should null. We'll do that. Bo asks, is there a way to check what part of the code is hogging the CPU? What you're asking for has a name. It's called profiling. Is there a way to profile JS effects? And the answer is, I don't think so. At least you have a measurement of how much CPU your plugin is taking, but I think that's all you get. So I will have to like tweak parts of the code, like for instance, turn off the error checking and look at the CPU. And I think that's the way to go. Okay, so what I have to do to null this is I have to change the pins. So the track channels, I will need to have 4 of them. And this white noise situation, I'll have to do all sorts of weird tricks here with the routing. So check this out. I don't need any inputs for my white noise, but I do need outputs. And I'm not going to output this like this. So my JS output on channels, my white noise generator, this white noise generator that I'm using here, is going to produce different white noise for all the different channels. So what I'm going to do is I'm going to take these 2 channels, which are one source of white noise, and I'm going to output them to both 1 and 2 and 3 and 4. Then over here on my implementation of the RBJ filters, I'm going to listen for inputs coming from 1 and 2, and I'm going to output to 1 and 2. On ReaEQ, I am going to listen from 3 and 4, and I'm going to output to 3 and 4. Then on I'm going to add this effect, which I wrote in one of my streams a long time ago. And what it does is super simple. It's just going to subtract the channels. So this is going to perform a null test. All I have to do is do it like this, the pinning like this, and it's going to null test. For instance, if I turn off both EQs, then my null test is perfect. There is no signal passing through. If I enable one of the EQs, then we hear a lot of difference, mainly on the high frequencies that have been cut. And when I enable both of them, a null. Bo says, put them on different tracks under one bus, route the noise to both EQs, and then phase flip one of them via the track panel. What I'm doing is exactly equivalent to what you described. The main difference is that I'm doing this in a single track. And I'm using my little effect here to do that. But it's the same principle. I'm just using pins, ins and outs, instead of the track routing. It amounts to the same, doesn't matter. All right, so we have the ReaEQ and we have our plugin, and they're null. There is a null already. That's great. So let's add some controls to our plugin so that we can switch to different filter types and we can try to know other things. So I'll have a slider 2, not 2, I'll skip 2. I'll go to 3 so that there is a little gap. And I think I'm going to call this the RBJ filter type. Well, let's see what is that I need to configure. RBJ filter. Essentially, I think I'm going to need this options. I think there are some wrinkles, however. I don't need to actually have configuration here because I don't have anything opposed to that, like intermediate variables or normalized coefficients or whatever. So I think that is all good. Then for the filter types, they're going to be a drop down. I think I'm just going to say type. And what are our options? They are these options. I think I made a mistake. Okay, let's do this more slowly. I will have a low pass and so forth. I don't need to narrate this. Oh, my keyboard. Not the keyboard. I am operating the keyboard very badly today. I'm not being a good typist. There you go. And how many of them do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. So it goes from 0 to 8. And then before I continue with this other slider stuff, I'm going to put this in a temporary buffer. Now I will need a slider block. And when the slider changes, I will do something similar to this. So in this case, I don't need to configure here because I will configure here. And in this case, I don't need to set all of that because that has already been set. So what I do need to do is to get the filter. So I need to do this bit. So when you switch the slider, this is my RBJ filter type. And I think that this is correct. What is this number 2 again? I forget. Oh, it's the bandwidth. Okay. So everything is muted. We're not gonna hear anything crazy in case it goes wrong. Let's reload. And then we are doing, oh, this type should not be showing up, but never mind that. We'll fix that later. So my type is now doing a low pass. Let's turn off this whole null test situation. Why is it silent? It's not passing any audio through. That cannot be right. Okay, there is a mistake somewhere. I'm an old analog dog. I learned routing with tracks and patch base. The pin stuff has me buffed. Well, but I mean, isn't it like connecting wires on some modular synthesizer? It's very analog. Oh, we have some situation here with the UI and everything. Okay, I'm gonna deal with this later. Why is this muting everything? Yeah, let's deal with this stuff one step at a time. Oh, I think I already know. These numbers don't correspond to the enumeration, so that's what's up. Okay, that's easy to fix. But let's start here. No, here. This variable doesn't really make sense anymore, so I'm going to inline that. No, I really like these lines. I really hope that we can pull this off because it is so readable. I mean, you are initializing an array, looping over, blah, blah, blah. Super cool stuff. Okay, the problem here is that my slider options don't correspond to the enumeration. So I think I'm going to call this like, yeah, I'm going to call this the RBJ filter type slider. And then on the slider block, I will define RBJ filter type is equal to if my slider, let me do this in bulk. If my slider type is equal to 0, then dash. Otherwise, and then I just have to update this. I don't like how I have to write this, but I think it's the only way to do it. Or something that amounts to this. But in any case, now the RBJ filter type will have its correct value. So this is going to probably work now. Let's see. Full compile reset. And then switch to dash. And it is now doing a low pass. Let's do a high pass. And it is now doing a high pass. And let's do a band pass. Then a notch, null pass. A peaking doesn't look good. A low shelf doesn't look good. We may have some bugs somewhere. This is a very loud noise, isn't it? Okay. Bo says, yeah, but tracks plus buses are way more visual. My brain works better with visuals. I think there are some, not to like say that that you're not doing it right. Do whatever you like. But I think there is a way to see this, like with what is it called? Track wiring. See, I think that this helps. If you do something like this. This is very visual. Oh, the CPU went through the roof. Yeah, that's fun. So I can see like the white noise. Is it connected to these locations? Yep, it is outputting to 3 and 4. And then there is this, there is that, and then everything. And then the frequency spectrum is listening to that, and the fader is listening to that, and that goes to master. So yeah, I find that this is helpful sometimes. You may want to check that, or you may not care and continue doing the way that you do it. It's fine. Okay, so let's just try a high pass. Let's try to null a high pass. It nulls. Hooray! Oh, and the CPU went through the roof, you said, but that was when we were... Oh, a high pass is slower, but it doesn't go through the roof. So it seems like a low pass is now also slower. I don't know. But when I go to a low shelf... The CPU is constant, so I don't know. Probably was something else, right? Yeah, all right. What do we have here? We have that, and what are we still missing? We are missing all these other sliders. Can I do comments like this in this part of a JSFX? Is it going to be happy if I do this? Seems like it is happy, but it is presenting other sliders? Yeah, this doesn't seem commented out. Yeah, whatever, I think I'll just do it like this. And it seems to be happy anyway, so whatever. But I will leave a comment here saying to do. I don't need that. I think I will remember that. Okay, so I'm going to wrap up now, and there are some good news and bad news. Good news is that our filter seems to be working, at least 2 of them. Bad news is that it is slow. We'll have to think about that. I don't know. On Monday, I'm going to be working on Aria's blog. I think it will be our last session, hopefully. We'll finish migrating everything, and then we'll leave it to him to do the rest of the pages and verifying that the blog worked, that the blog posts are successfully migrated. He's going to check everything by hand, I think. And on Tuesday, I'm going to get back to this. It's going to be weird. We'll probably work on the performance thing, which I think is like the most pressing issue. Yeah. Thanks for being here. Thank you both for always being active on the comments, on the chat. That makes me happy. Have a good weekend. Yeah, thanks for supporting me in all the different platforms and everything. And I see you back here on Monday. Bye.